Every photo you've ever taken is secretly a giant list of numbers. Each pixel stores three values: red, green, and blue. A typical photo, say 512 by 512 pixels, contains 786,432 numbers. AI takes all these numbers and stacks them into a single mathematical object called a vector. To AI, this cat is not a picture. It is a single point, floating in a 786,432 dimensional space. And to understand modern AI, you need to understand how math moves these points through space. This is the language AI speaks. Mathematicians see a vector in three different ways. First, as an arrow. An arrow has a direction and a length. This arrow points to 3, 2, meaning 3 steps right and 2 steps up. Second, a computer sees this same vector as a list of numbers, 3 and 2 stacked in a column. This is how every AI actually stores data. And third, geometrically, a vector is a point in space. 3, 2 marks a specific location, a single dot on this plane. Arrow, list, and point, 3 views of the same idea, and this idea scales to any number of dimensions. In 2 dimensions, a vector has 2 numbers. In 3 dimensions, 3 numbers. In 786,000 dimensions, the same idea, just a much, much longer list. Once you see vectors, you see them everywhere. A 1,000 by 1,000 pixel photo, each pixel has red, green, and blue. That's 3 million numbers, a vector in 3 million dimensional space. But here's where it gets really interesting. AI can also turn words into vectors. In a model called BERT, the word king becomes a vector with 768 numbers. The word queen becomes another vector nearby, and the distance between them captures their meaning. Even you are a vector. When Netflix recommends a movie, it represents your preferences as a vector with about 50 numbers, how much you like action, comedy, drama, and dozens of other hidden features. This is AI's most fundamental trick. Convert anything, images, words, people, into vectors. Then let mathematics operate on them. If vectors are the nouns of AI, the dot product is the most important verb. It works like this. Take 2 vectors, multiply matching entries, then add them up. That's it. But what does this number actually mean? Geometrically, the dot product measures how much 2 vectors point in the same direction, scaled by their lengths. If they point the same way, the dot product is large and positive. If they're perpendicular, 90 degrees apart, the dot product is exactly 0. And if they point in opposite directions, it's negative. In AI, the dot product answers one question. How similar are these 2 things? Similar words, high dot product. And here's the preview. When ChatGPT reads your message, it computes billions of dot products to measure how each word relates to every other word. This process is called attention, and it's the beating heart of modern AI. We'll build it from scratch in episode 12. Now we have vectors, lists of numbers representing data. But how does AI process these vectors? With matrices. A matrix is a grid of numbers. But don't think of it as a table. Think of it as a transformation, a machine that takes one vector in and pushes a new vector out. Watch what happens when a matrix transforms all of space. Here's a grid. Every point is a location. Now watch. The matrix moves every single point all at once. Squares become parallelograms. Circles would become ellipses. But notice, straight lines stay straight, the origin stays fixed, and parallel lines remain parallel. That's what makes it a linear transformation. Here's the beautiful insight. See these 2 arrows? The green one, I hat, and the red one, J hat? They started at 1, 0, and 0, 1. After the transformation, I hat landed at 2, 0.5, and J hat landed at 1, 1.5. Those are exactly the columns of our matrix. The matrix tells you where the basis vectors land, and that determines everything. In a neural network, every single layer multiplies the input vector by a matrix. Training the network means finding the right numbers to put inside these matrices. That's it. That's what AI training really is. If one matrix is a transformation, what happens when you apply 2 in a row? First, matrix A transforms the grid, then matrix B transforms it again. The result is a single combined transformation, and that combined transformation is itself a matrix. the product A times B. This is exactly what a deep neural network does. Layer 1, multiply by matrix W1. Layer 2, multiply by matrix W2. Layer 3, multiply by matrix W3. A deep network is a sequence of matrix multiplications. But wait, if each layer is just a matrix multiplication, why not collapse all the layers into one giant matrix? The answer is the secret ingredient. Between each layer, the network applies a simple nonlinear function called RealU. RealU does one thing. It keeps positive numbers unchanged and replaces any negative number with 0. That tiny change makes all the difference. Without it, 100 layers would be no better than 1. With it, deep networks can learn almost anything. We'll explore exactly why in episode 6. Everything we've seen, vectors, dot products, matrix transformations, works in 2 dimensions, but real AI doesn't work in 2 dimensions. In GPT-3, each word is a vector with 12,288 numbers. The matrices contain hundreds of billions of entries. GPT-4 is estimated to be far larger still. These numbers are almost impossible to visualize. But here's what matters. The same math works in any dimension. The dot product, multiply and add, whether it's 2 numbers or 12,000. Matrix multiplication, same recipe, just bigger matrices. This is the extraordinary power of linear algebra. The tools you've just learned scale from a classroom whiteboard to the largest AI systems ever built. Let's step back and see what we've built. Everything is a vector. Images, words, people, all represented as lists of numbers. The dot product measures similarity, how much 2 things point in the same direction. And matrices are transformations, machines that reshape space itself. These 3 ideas are the foundation of every modern AI system. Next time, we tackle the question every AI must answer. How do you find the right numbers to put inside those matrices? The answer is gradient descent, navigating a vast landscape to find the lowest valley. And in episode 3, we'll discover how AI handles uncertainty with probability and Bayes' theorem. If you want to understand the math that powers modern AI, subscribe and hit the notification bell so you don't miss the next episode. New episodes every week. See you next time.